We're discussing about mathematical convention and perspective relevant to extraction process because we are talking about two different liquid phases. In between them, one target compound is getting partitions. So the convention is like that: heavy phase, the original phase containing the compound, we are referring volume as H, and initial concentration in heavy phase as Yi, initial concentration Y. So here we are talking about heavy phase. So volume and concentration representations we are showing here. Similarly, we will also have a light phase, that is the organic liquid, where volume is L. And initial concentration in the organic phase we are assuming as 0 because the fresh solvents we are using for extraction process. So representing here L and Xi equal to 0, approximately 0. And these two phases are coming in close contacts, they are mixing up. So there is a partitioning of your solute between these two phases. And so mixing and separation. Once separation is done, we are giving a nomenclature for the heavy phase concentration as Y and similarly lighter phase concentration as X. So if we put a mass balance, the total amount of compound before extraction across the two different phases and after extraction, we can have a mass balance relationship and also one partition relationship because these are later phase is actually in equilibrium, later phase and heavy phase. So this concentration ratio is also a constant. So these two things as in equilibrium is there, we can write it down. The mass balance equation, that is volume into concentration before partitioning in the heavy phase, that is H into Yi. In the liquid phase, the organic phase initial concentration was 0, so amount was essentially 0. But the later on in the extraction process, once they're in equilibrium, heavy phase concentration is Y and lighter phase concentration is X. So total amount is Hy plus Lx. Same way we are also doing for original one. So original phase also we know. So Hyi. So basically this is a mass balance equation which is coming from the two different components, the total amount of compound in the mixture. And also we are having a partition coefficient, that is x by y equal to k or x equal to ky. Now these two equations we can combine so that we can estimate the concentration at the latter phase or amount of product recovered. All those calculations can be done based on these two principal equations. One is partitioning, another is mass balance. In a simple mathematical sense, if I represent the same thing what we discussed earlier, initial x0, y0, later on x1 and y1 after one step of extraction process, we can use the first one mass balance equation and second one is for equilibrium. And now we'll be replacing x1, that is the liquid phase rather than liquid. I'm saying that lighter phase concentration after partitioning. Then if I replace these values there, our equations can be more simplified. And same way we can go for batch or cross or counter current extraction, which is a repeated one. So we refer one terminology, that is extraction factor, that is how much amount is present in latter phase after extraction and how much remaining residual is there in heavier phase after extraction, that is L into X by H into Y, which is essentially X by Y is partition coefficient. So we can write like LK by H. This is called extraction factor, ratio of amount in latter phase to that of the remaining heavy phase. Fraction extracted, basically how much total amount is getting extracted, amount recovered in the latter phase to the original amount we have in our heavy phase. So basically that times what will happen, Lx divided by Hy plus Lx essentially. So if we just make it simplification over here, we can represent this one also as Lx by Hy and this portion also coming back together at the denominator. Lx by Hy, that is actually known as extraction factor. E we have already defined. So fraction extracted is basically E by E plus 1. Essentially, always this fraction will remain less than 1. On simple problems, we are showing here in the steps, water containing acetic acid is extracted with pure benzene. And we can see, we can calculate the equilibrium concentrations in the organic phase, extraction factor, fraction recovery. Based on the data, equilibrium constant is given as 180 and ratio of water to solvent is 80. Now, assuming that here benzene volume is 1 liter and water volume is 80 liter, because the ratio is given. So basically, we can say that water is 80 liter, solvent is 1 liter. That ratio we are going to utilize it here. So total acetic acid in the water phase before extraction is becoming 7 milligram per liter originally, and 80 liter was there, so 560 milligram. Final aqueous phase 80 liter, concentration I do not know, we are assuming as Y milligram per liter. Final benzene phase concentration will be 180 times, because partition coefficient is given 180, so it will become 180 into Y milligram per liter. So total amount is 80Y plus 1 liter into 180Y, so basically 260Y milligram. That we already know, because initially our total compound was 7 milligram per liter into 80 liter, 60 milligram. So essentially I'm getting Y. Once we find out Y, that is the final concentration in aqueous phase after extraction, we can find out the extraction factor as well as fraction extracted. So extraction factor is coming as 2.25 and fraction extracted is 0.69. These are very simple problems on this aspect. We'll have some quiz there. Now, there are 3 different mode of operation we can have. One is known as, for example, in the first case, this is one stage. Stage basically is mixing and separation. So 3 different stages are shown. Feed is coming from left side, while the fresh solvent is coming from the right side. So basically they are interacting. So feed is getting devoid of the target compound as the stage proceeded. So raffinate, last phase we are talking as raffinate 3, coming out of the third phase, stage. Solvent is here. So coming out of the stage 3 is extract 3, extract 2, and extract 1. So extract 1 is already enriched with your target compound. So this approach is known as countercurrent. The second one is known as cross current. So basically in each stage, some amount of solvent is coming in contact with the target compound. Feed is moving from stage 1, stage 2, stage 3. But solvent is not like this scenario. Rather than each stage, they're having their own extract and we can finally join it up. That is called cross current extraction process. And the third one is feed and solvent moving in parallel across different stages. So these are known as co-current extraction method. And we can compute the recovery of given byproducts in repeated batch extraction and stage countercurrent extraction modules. So I'll be showing this time about the process, how we are going to talk about. So essentially, a few mathematical conventions when I'm going to have extraction process in repeated manner. So first one is the partition coefficient, that is K equal to X by Y, and mass balance, because initial stage I'm having X0 and Y0 here. So essentially volume is H, because volume remain unchanged for heavy phase. Similarly, if we say the latter phase also like that. So I can say Hy plus Lx1 equal to Hy0. So we substitute this X as Ky. Ky means at the first stage, second stage, we can have like Ky1 after partitioning. So we can say Hy1 plus Lky1 equal to Hy0. So y1 is essentially, we can rearrange it and it is becoming y0 divided by 1 plus kl by h. So basically y0 divided by 1 plus e. Now similarly, when we will be doing for y2 second stage, because we are adding some solvent over there and processing it. So y2 will be the same way as we have done for y1. The same process for repeated one will be y1 divided by 1 plus e. So essentially this is actually y0 divided by 1 plus e into 1 plus e. So basically y0 into 1 by 1 plus e square. So 2 stages. If I'm doing the same process for n stages repeated, that means we are every time adding fresh solvents, and then we are going to extract it. And the concentration coming into organic phase is x0, x1, and x2, like that way. And our this phase is y0, first extraction y1 and y2. This way we can proceed. Then after n stage, we can have y0 into 1 by 1 plus e power n. N is the number of stages we are considering here.